Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Fatiha binti Muhammad An-Nairali and I am from RK93 Computer Network Engineering. So my supervisor is Dr. Muhammad Nasrun bin Osman, and today I would like to present my FYP1 with the title Mobile E-Waste Monitoring System with Image Detection. So what is e-waste? E-waste or electronic waste can be described as discarded electrical or electronic devices. The use of electronic actually are destined for use, resale, salvage, recycling or disposal are also considered as the e-waste. So informal processing of e-waste can lead to adverse human health effects and environmental pollution. This is the type of e-waste which is generated from the data processing, electronic devices for entertainment, for communication, household equipment, and audiovisual components. And as you can see in the slide, we have the cell phone, computers, monitors, printers, audio or videos, small devices, and other things of the e-waste. What is the effect of e-waste if we did not perform a formal disposal? So for the first one, on the slide, it will affect the human body, and the second one, it will affect on the environment. So for the human body, it will lead the chronic damage to brain and respiratory system and causes the reproductive and development problems. Next, for the environment, it will causes the soil pollution and health hazard. That is why there is some papers that propose a e-waste system in order to upgrading the method to dispose of the e-waste. For the next slide is about the problem statement. So regarding to this issue, such as a person need to manually monitor the status of bin, how to set the transmission to the cloud, and monitoring the system and detecting the image. So based on some research paper, they are using the ultrasonic sensor to measure the level of threshold, and it will automatically send a message to the concerned person. In order to send the transmission to the cloud, some papers are using GSM and some papers also using the Wi-Fi module. But unfortunately, based on the past research papers, they are not developing the image detection system. Thus, my project we try to develop a new technique using the edge detection algorithm to detect the image. There are three objectives for this project. So the first one is to design the mobile e-waste monitoring system that able to monitor the level of fullness of e-waste bins. The second one to develop an Android application for monitoring with the ability to notify the authorities for collection process. And the lastly is to detect and identify the type of e-waste such as the tablet, phone using the edge technique. Right, next we are moving to the scope of project. So the aim for this project is to be able to track the fullness of the e-waste at several places. So Raspberry Pi 3 of Model B had been chosen as the main controller board. Raspberry Pi are the chosen one as it fitted with Wi-Fi connectivity, and the Pi camera also can be set up to detect the e-waste. So the project also will implement the image detection based on the YOLO system, and ultrasonic sensor will allow the system to detect the level of garbage, and it will be shown through LCD. Next, the ThinkSpeak was chosen as it will send the transmission to the cloud and it will store the data, and the result can be monitored through the SMTP package. So as the conclusion, my project are limited to the Raspberry Pi 3, the Pi camera, servo motor, and also the ultrasonic sensor. Next part is the literature review. For this part, it discusses on the microcontroller, software, and sensor that have been used based on the previous research and the journal. So as we can see for the hardware, we have the Arduino Uno, Raspberry Pi, ARM microcontroller, IR sensor, ultrasonic sensor, weight sensor, Pi camera, Wi-Fi module, and so on. For the software, we have the Blink apps, ThinkSpeak, Fast RCNN, and also the RCNN. So this is the type of software and hardware that have been used from the previous journal. Next slide is a SOTA table. Basically, I managed to get 60 research papers, but in this slide, I will focusing several papers that are related with my project. So for the first one is the IoT e-waste monitoring system to support the city initiative. So for the limited for this system is does not have the push email or notification to notify the client or of the new message. Second paper, I choose the smart dustbin for smart cities. As you can see, the limited for this paper, this fixed schedule is if one dustbin is filled early, so it will be left unnoticed until the next interval of collection. Next paper is Smart Solid Waste Monitoring and Collection System. This system just store the data in the SD card by using the Arduino Mega instead of transmit into the cloud. Next paper is IoT Smart Garbage and Waste Collection Bin. The limiter is the important message does not send directly to the garbage collections, but the system will notify the contractor office. Next paper is segmentation and object recognition using the edge detection technique. Unfortunately, this system does not perform any monitoring system. Next. The next paper is about the application of the deep learning object classifier to improve the e-waste collection planning. And the last paper is also about the implementation of SIFT for detection of electronic waste. And these two papers also does not perform any collection process, any authorized for the collection process or monitoring the level of fullness of the e-waste. So for the chapter 3, methodology. Based on this architecture diagram, this system uses the Raspberry Pi as the main board and it will communicate via the internet. The Raspberry Pi attach an ultrasonic sensor to the lid of the bin, where the ultrasonic sensor will provide the data of the distance left to fill up the e-waste in the bin. An Android application also designed for users to view the bin status and the bin location access. Then the email alert will be sent to the authorized person by using the SMTP package working with the Raspberry Pi in Python. And finally, the Raspberry Pi will send all the data to the cloud storage ThinkSpeed. There are two main parts for this project, which is the hardware and software for the Android application. The hardware part is separated into two, which is the ultrasonic sensor and the Pi camera, where the output of the component will be the LCD display and the servo motor. Next, the Android application is the software that used to monitoring the bin status, where ThinkSpeed is linked and the email is sent using the SMTP package in Python. As you can see, this is the overall flowchart of the system design, and I will explain more details based on each flowchart. For the flowchart of monitoring system and the flowchart of the level of e-waste. As for the monitoring system, the lid of the dustbin will open for 10 seconds and the process will be repeated once the lid is closed when the power supply is switched on. Next, the Pi camera will identify whether the waste that had been deposited is an e-waste or not, and if the waste is not the e-waste, the lid of the dustbin will reopen to remove the waste. So next, to measure the left distance to places e-waste, ultrasonic sensor will send a signal to the Raspberry Pi, then the level of percentage of e-waste will be uploaded to the ThinkSpeed application, and in a real time the Android data are collected from the ThinkSpeed application. So, when the percentage of the e-waste exceeds 90%, the email alert will be sent to the concerned authority. Next, we move to the flowchart of the level of e-waste. So, for the level of the e-waste, by using the ultrasonic sensor, after a certain time, the ultrasonic sensor can sense the level of waste and trigger the e-waste, distance and percentage accordingly. So the ThinkSpeed will store the calculated data that have been uploaded when the LCD screen displays the e-waste percentage and distance. When the level of e-waste is above 90%, the email alert will be sent to authorized person, or else the alternate sensor will keep in the reading the data after a certain time. So for the flowchart of Pi camera, which is data monitoring system, we start with initializing the Pi camera. By using the CSI connector, the Pi camera is connected to the Raspberry Pi. Then the Pi camera will capture the image of the e-waste, and Raspberry Pi will read the data that had been captured by the Pi camera. So the data will process for further action, which is to identify whether the waste that had been captured are e-waste or not. So next we move to the image detection. We are using the YOLO system, which is the real-time object detection. It will be start by the initialize of the Pi camera and detect the image. The input image will be resized to the 448 times 448. When the object is fall on the grid will immediately take an action to predicting the objects. So the predicting of these boundary boxes will represent the level of confidence for the object in the box. Next, the boundary boxes will be calculated that include 4 parameters, which is x, y as the center location of the boundary box, and wh is for the width and the height of the box. Then each grid will predict the probabilities of C conditional class, and these probabilities are determined on the grid cell containing the object. So lastly, the multiply of the conditional class probabilities and the individual box confidence prediction will give the class-specific confidence score for each box. There are 4 software that have been chosen to complete my project. So as you can see, there are MIT App Inventor, ThinkSpeed, SMTP, and TensorFlow Lite. So I choose MIT App Inventor as it is an easy medium to learn and also user-friendly. For the ThinkSpeed, it can store and manage the data and collect it, and it will be transmitted to the ThinkSpeed also. After that, I choose the SMTP because it will send out the email alerts to administrators when the mobile erase is over the threshold in the bin, which is 90%. And the last one, I choose the TensorFlow Lite because it is used to achieve the object detection part. For the hardware, as you can see, I already put the configuration part between the between the hardware and the Raspberry Pi. So the first one for the Raspberry Pi, it will receive the data and the data will be sent to integrated components. Next, the LCD will display the level of fullness of the waste. Third, the Pi camera, it will be placed at the top of the bin and detect the e-waste. After that, the servo motor will be attached to the lid to keep control the bin lid, and lastly, the ultrasonic sensor will transmit and receive sound information to determine the distance between the transmission of the object. As for the conclusion, electronic gadgets without the proper disposal can cause the environmental harm. The second one, reuse and recycle are more beneficial than the simple disposal. And the last one, designing of the products using the environmental friendly raw items can make a change. So I think that's all for me. Thank you.